Dear friend, good morning. Today I will be talking about how to design the band gap. If you look at the circuits, there is a band gap circuit where there are three PNP transistor connection and R1 and R2, and there are two NMOS and three PMOS connection. So Q1 size and Q2 size, Q1 equal to M equal to 1, Q2 is equal to M is equal to 8, and Q3 is equal to M equal to 8. So R1 is connected to the Q2 and two NMOS transistor current as a diode connected, and the two PMOS connection as a current source, and then another PMOS transistor which is connected to the R2 and connected to the Q3, the BJT PNP transistor, and then VREF voltage is taken at the R2 node and PMOS the current source node. Yeah, and now if you write the KVL equation, which is equation number 1 minus BBE1 plus I1 R1 plus BBE2 equal to 0, and BB1 the equation is BTLN I1 by A ISS, where A is the area of the BJT, and BBE2 is BTLN I1 divided by A ISS times N. N is the size, where N is the ratio of Q1 and Q2 area, where N equal to or M equal to 8 in the above figure. Bt is equal to Kt by Q, where K is Boltzmann constant. Now go to the next page. So now K value we know 1.38 into 10 to minus 23 meter square kg second square, and inverse of the Kelvin equal to 1.38 times 10 to minus 23 joule per Kelvin degree. So now Q equal to 1.6 times 10 to minus 19 coulombs is the electric charge, and Vt equal to Kt by Q, which equal to, if you look at 1.38 10 to minus 23 divided by 1.6 times 10 to minus 19 multiplied by 300 equal to 26 millivolt. So Vt is equal to 26 millivolt. From equation 1, BBE1 minus BBE2 is equal to I1 R1. Now if you put the BBE and VB2, you will get the equation like Vt ln I1 divided by ISS times A minus Bt times ln I1 divided by NISS times A equal to I1 R1. Now Vt within the bracket ln I1 ISS divided by A minus ln I1 N ISS times A within the bracket equal to Vt ln I1 ISS by A times N times ISS divided by A1. If you simplify this equation, you will get Vt ln N equal to I1 R1, which is I1 equal to Vt ln N divided by R1, which is equation 2. V reference equal to Vt ln N divided by R1 multiplied by R2 plus BBE2. So if we put the values 0.7 plus 26 millivolt times ln 8 divided by R2 by R1. So now choose R1 equal to 1 kilo ohm and R2 equal to 8 kilo ohm. So now V reference equal to 0.7 plus 26 millivolt times 2.0794 times 8. 0.7 equal to 0.7 plus 0.4325 equal to 1.325. Now V reference equal to VBE plus MBT, where BB is equal to negative temperature coefficient, which is minus 2.2 millivolt per degree centigrade, and MVT is equal to positive temperature coefficient, which is 0.085 millivolt per degree centigrade, where M equal to 2.0794 times 8, 16.6352. And if you see this below diagram, which is the I bias on the diode, I bias which is coming from the diode or VBE, BD or VBE, and that is summed with the VT, the multiplied by the multiplication factor K, and which sum together and which is called the VBG, the voltage of the band gap reference. Hope this is helpful to design your band gap reference. Thank you.